Hello, today we're going to be using our Desmos to do our lesson 751. It's our first lesson in Unit 5. This lesson is where we really dive into positive and negative numbers, or we call them integers, both positives and negatives. And we learn how to put them in order and also kind of to be able to see, well, what's the difference between positives and negatives? So, the first slide is just a little check-in to see how you're doing. The second slide, we're looking at this thermometer and you're asked to figure out what numbers go in these little boxes, right? So go ahead and hit pause and fill that in to the best of your ability. All right, so let's take a look at what we're doing here. The whole idea of this was, can you understand the scale of a thermometer? Simply meaning when we see these lines on the thermometer, what is it going up by or down by each line? So looking at this, there's different ways to do it. You can notice, oh, look, there's 15 and then the next one's 20, right? So I know that's a difference of 5 degrees Celsius. Or there's also one here. If you go from 0 to 5 degrees Celsius, again, that's a change of 5 degrees. So I know that every line is going up or down by 5 degrees. So I'm actually going to start with C because in my opinion, that's the easier one. So I know if this is 30, 5 less than 30 is 25. So I know that that is 25 degrees there for C. So I would put 25. You actually can't put in the degrees Celsius, which is not awesome, but you'll just put the number in for there. For B, I know it's between the 5 degree and the 15 degree. So I know it's 510. B is 10 degrees Celsius. And then for A, I know that it's less than 0 degrees and it's 5 degrees less than that. So I also noticed this is a negative 10. So because we're going below 0, less than 0, that's when we start using our negative sign. So that is negative 5. This question asks me, what is the temperature on the thermometer? So when I look at the thermometer, I see that this gray area here ends right there. So we have to figure out about how many degrees is that. So I get a mixture of answers for this one. If I know that this is negative 5 and this is 0, it's got to be between those two, right? So if I were to draw, I'm just going to draw a quick little number. It's not a very good one. Let me try that again. If I draw let's say that this is the thermometer, but I'm going to zero in on what we're looking at. So if this is 0 degrees and this is negative 5 degrees, right? Well, I know that between those two, it's going to look something like this. There's 5 degrees, right? So if I were to, I'm going to break this up the best I can, which is not always great. We'll pretend like those are all the same distance. I know that these are the temperatures between 0 degrees and negative 5 degrees, right? So it's kind of like a backwards number line. So it goes 0, negative 1, negative 2, negative 3, negative 4, negative 5, right? It's going down, counting down, right? So when I look at this, to me, I know that it's closer to 0 than 5, right? The negative 5. So that tells me it's got to be, my poor drawing is terrible here. It's going to be somewhere in this area here, right? It's going to be between negative 2 and negative 3. So I would accept answers that would look like negative 2. I would accept negative 3. And I would really accept anything in between there, like negative 2.5 is also a common answer. Or some people write it as negative 2.5, and that works. Okay? You only have to have one of those answers, right? And then make sure once you do that, you do hit the submit button. All right, so now let's look at these. We're actually being asked for this one to do the same thing, except we're really just reading the temperature for each thermometer. So I want you to try first. Go ahead, fill in these boxes on your own. Okay? And now I'm going to look at this and we'll look at each one and fill them out. So on the first slide, or really the second slide, we knew this scale or what this thermometer was going up by was by fives, right? Every 5 degree. So it's important for us to understand what's happening on each and every thermometer we look at because they're not all the same. So for this one, I'm noticing that every line is actually going up by 1 degree, right? So this is 0, 1, 2, 3, 4, right? And then 5, 6, 7, 8, 9, 10. So it's going up by 1. So that means A is going to be reading 4 degrees. And I'm looking at just an observation. They're all doing that, right? Every single one is going either up or down by 1 degree each line. So this one I'm noticing is a little different because this one was above 0, this one's below 0. So I know it's reading 0, -1, -2, -3, right? Because then that would be -4, -5. So this is actually -3. It's very important you put the negative sign in front. If you don't, then you cannot, we wouldn't know if you're talking about positive or negative. Okay. The third one, C. Okay, this is where it gets a little bit different because now I'm noticing it's not exactly on a line on the scale of the thermometer, right? So I'm looking at this and I'm saying, okay, if that's 5 degrees, this is 6 degrees. So I know that the temperature is somewhere between 5 and 6. And in this case, it looks like it's exactly in the middle. So that's actually going to be 5.5 degrees, or some people also write 5.5, and that's the same thing, so that's okay. D, this is the one that gets a lot of people confused. All right. When we're looking at this again, it's just like the last one, right? It's not on an actual line. And here's the thing that confuses people. All right. The most common answer I get for this problem is that the answer is -2.5 or 2.5 degrees. This is wrong. All right. And here's where I want to show you why. Okay. I'm going to draw a line. So we're going to pretend like this thermometer is the same, but we're going to rotate it so that it's actually going left to right. So instead of standing straight up, it's going to be going left to right. And this thermometer is much like a number line, right? And so if we would have, this would be like 10, right? Over here, this is like the -5. Okay. And what I'm going to do here is kind of show you, we'll pretend like this is 0 degrees. Okay. Now each one of these is a degree, right? Just like before. Nothing's changed about that. So looking at this, it's going 0. This is -1 here, right? So this is -1, and we know this is -2, right? So on here, here's -1, right? And this is -2. So we know whatever it is we're looking for is about right here in the middle of the two, right? So here's where it gets tricky. If I were to ask you, oh, what's between 1 and 2? So I'll even put this out here. What's exactly between 1 and 2? The numbers 1 and 2. So if this is +1 and this is +2, what's exactly in the middle of those two? Oh, it's 1.5, right? 1 plus an extra half, right? This is the same question. The only difference is we're going backwards. And so a lot of people, like if we were on a number line that was positive, if we said, oh, look, a little more than 2 would be here, so it's 2.5, right? That's 2.5. However, over here, it's between 1 and 2, or -1 and -2. This is actually -1.5, right? Because 1.5 is between 1 and 2. So the number line is actually backwards, all right? It's actually backwards from the positive side of the number line. So that number is -1.5, right? And we just have to be very careful about that. So let's take a look here at the next question. So when you hit submit for those answers, it says which one's showing the highest temperature, right? So there's a lot of ways you could look at that. Some people look at this and go, okay, well, 5.5, right? C, right? You look at the numbers. Some people can just look at the thermometer. Well, the higher the temperature on a thermometer means the higher up it is on the thermometer. So I know this C is the highest temperature. Okay. Okay. Which one shows the lowest temperature? So this is like the exact same as what we just did, only opposite. So if on my thermometer, this is the highest, right? Because it goes higher than any of the others, we can look at here and see, well, which one goes lower than the other ones, than any of the other ones. And a lot of people pick -1.5. A lot of people pick D, okay? But that's not true. It's not true. Think of it this way. Looking at our thermometer here, which here's the -1.5, right? Its temperature goes here, but look at this one. It's lower down, right? The thermometer goes lower than -1.5. Again, and that's because our number lines kind of go backwards once you get below 0, right? So the farther away you get from 0, the colder it is. So really for this, the answer is B. Okay. All right. So we're going to hit submit and move on to the next slide. All right. So suppose that the temperature outside is -4. Is that colder or warmer than the coldest temperature shown? And looking at this, these are the exact same thermometers as our last slide, right? So I'm going to look, we said that this was the coldest one, B, right? Because it actually goes lower than this one here. So on here, let's go ahead and mark where is -4 degrees. If that's 0, that's -5. We know we're going 0, -1, -2, -3. So here is -4. Whoops, I'm not very good at drawing those lines. So if that's -4, that's actually lower than the coldest temperature, isn't it? So since -4 is lower down on the thermometer, that means it's actually colder. And so again, I can explain my thinking based on what I just talked about. I know that -4 is colder because it is lower down on the thermometer than -3, right? I also know that -4 is 4 away from 0, and -3 is only 3 away from 0. So it so -3, I should say, is closer to 0. And being closer to 0 in the negatives means that you're actually at a higher temperature. Okay? All right. So here's where we're going to take a little bit of a different take on the positives and negatives, and we're going to be using some sea animals. So this graph is just showing, notice that says vertical position or meters. Vertical position just means how far above or below sea level, which is here, right? Zero is sea level. That's where the water meets the air, or land. So we're going to be telling how far above or below sea level is each animal. And it says to measure their eye level. So you can see their eyes, they're like little white spots. Okay. So the seagull, how far above is it? Well, it's the distance is actually 10, right? 10 meters. The dolphin, and again, we are using its eye, which is right here. Okay, so there's that. So I'm looking, I get several different answers for this. I look at this and I think it's about halfway in between 0 and 5, right? So personally, I would say that it's at about 2.5 meters from sea level, right? Um, the distance here is 2.5 meters. Some people say it's 2 meters. Some people say it's three. Either way, I would accept two, 2.5, or three. Okay. Here's our penguin. The penguin is actually, it's at sea level, right? So how far from sea level is it? It's 0 meters from sea level. Okay. The shark. Here's our shark. So I kind of, sometimes, it's probably better to draw a line. So I draw a line from the shark's eye over. Um, and so I'm looking at this. So again, this is like the positive, this is below sea level, right? So probably, I'm thinking that's -3, right? But the question is how far above or below is it? So it is actually 3 meters um below. I guess we should have said above, right? Above for all of these. Okay. All right. The next one is so 0 meters, it's not either. The next one's the fish. So here's the fish. Again, I'm going to draw a line over to see where it's at. Okay. And so I'm looking, so if this is 10, which by the way, I can see this octopus is about at 10 meters below. So I'm just going to fill that in. Again, I looked for the eyes. The eyes are kind of in the middle of where that octopus is. So if I know that this is -10 and this is -5, um, -5, so -5, negative, probably should let me erase this. Okay, whoops. So if that's -5 and this is -10, it's probably going to be -5, -6, -7, that's probably a little too close, 8, 9, 10, right? So again, this one, I probably want to fix this. Looks to me like it is very close to being between -7 and -8, right? So this is like -7, so -5, -6, -7, -8. So what's between -6, or I'm sorry, -7 and -8? Well, and it's actually -7.5, right? It's halfway between 7 and 8, so that's 7.5 meters below. Oops. Now, I would accept probably -7, or 7 meters below, 8 meters below, 7.5 meters below. I would accept all those. Okay. All right. So here's some more questions. James and Andre disagree about the answer. James said that the answer for the octopus should be 10, while Andre says it should be -10. So what do you think? Is Andre right? Is James right? Are they both right? Are they both wrong? So take a second to think that through. Um, all right, so I guess it kind of depends on what we're looking at. Like when we look at what we did up here, or what I didn't use any positives or negatives, right? However, this is saying how far above or below. If we're just talking about the distance from, right? Um, well, technically they both could be right, right? Or the distance from, well, James is right. 10 meters, he's 10 meters, right? Whether it's negative or positive doesn't matter. He's actually 10 meters away, right? This distance is 10 meters, right? Just 10 is the distance, right? If we were to say what position is he in, what position, we would say -10, right? Um, However, I can also see the other side where Andre says it should be -10. Well, the negative actually is giving us this information, right? So mathematicians can use a negative sign to show you a position where somebody or something is at, right? So this we just have to understand what negatives mean sometimes, right? Um, the negative tells us that it's below sea level. So I would say they're both right, and I would explain why, like what we just said there. Um, you could argue it in different ways. As long as you explain your thinking there, and it's showing logical thinking, it would be considered correct. All right. So for slide 6, we're looking at our animals some more. All right. Except they're adding in something called a mobula ray. And if you watch this video here, it actually will show you what a mobula ray is. So let's kind of watch. I'm going to turn the volume down. So this is the ocean. It's going to show you some, oh, there you go. There's some big stingrays is basically what they are. They like to jump out of the water. I've actually seen this happen. It's crazy and scary at the same time, right? So there's a close up, right? So in our lesson, it says that a mobula ray jumped 3 meters above the surface of the ocean. Draw a line on the graph to show the height of the mobula. Okay, so I'm going to I have my line tool selected. So it says 3 meters above. All right. The first thing I'm going to do is just kind of make some marks on here to show everything. Whoops. See, sometimes I'm not good at drawing lines, so don't worry if you're not. So if this is 5, I know the middle is 2.5, so it's going to be 3, 4, 2, 1. All right, so that's just helping me out to know where to go. So I'm going to draw a line. So here's 0, 1, 2, 3. And I know my ray is going to be 3 meters above, right? So I'm just going to go ahead and put M here. So I know that that's for the mobula ray. All right, so that's showing 3 feet above. Now, this is saying what's the directed distance that the mobula is above positive or below negative for the following animals. And that's really just saying that, so like here it's saying directed distance. All that's really trying to say is that a distance is never really going to be negative, meaning you can't say, oh, I walked -2 miles. You can't take back or go negative in a distance. However, in this case, the negative is just showing you in which direction. So that's why it says directed distance. Okay. So they're just basically saying fill in where the animals are using positives and negatives. Okay. So the seagull, well, we already did this on the last one, right? So we kind of already know these. So the seagull was 10 meters above. So I personally write 10. And the reason why I don't write, because I do have a lot of students who will write a positive, a plus. There's nothing wrong about that. It's just that typically it's understood as a mathematician that if you don't have a positive sign, If you just have a 10, it means positive 10, that we just know that, right? We know our penguin is at 0. 0 is not a positive. It's also not a negative. It's just 0, right? Because it's at. And then we know the fish. What did we say the fish was? The fish was at 7.5 meters below. So because the fish was at below, we're going to write negative 7.5. All right. And now that is our direct distance. Okay. All right. So now we have an albatross. And I'm going to show you, this video again shows you what an albatross is. I will talk to you about it instead of watching the whole thing. So an albatross is a bird, and it's a really big bird that flies around the ocean. So you can kind of see it's huge. They have really big wingspans. Okay. So here's what we're going to do. On here it says, which I'm noticing a little error, it says draw the height of the mobula. They really want the height of the albatross. And it's saying that it was flying 5 meters above the ocean. So I know at 5 meters above, I'm just going to draw in my albatross. So I'm going to put that. I'm going to mark it as an A for albatross. And now I'm going to, we're doing the same thing here. What's the directed distance of the albatross? Well, it's just 5, right? It's positive 5, but we don't write the positive sign. The dolphin, here's our dolphin, right? We said that that dolphin was at about positive 3, right? It's like he jumped 3 meters up. So we're going to say 3. And remember, it's just 3. The seagull, we know, is at positive 10, so it's just 10. And the octopus is actually below sea level. So to show that it's below, we put the negative. So negative 10. Okay. All right, next we have a clownfish. So let's take a look at what a clownfish is. Okay, so here's a maroon clownfish. In fact, I thought clownfish are simply Nemos, in case you have ever seen Finding Nemo, right? So here we have this clownfish, and it's saying that the clownfish is 2 meters below the surface of the ocean. We're going to do the same thing as before. We're going to find 2 below, so negative 2. Again, for this one, I'm going to draw out. So I always draw like, I know 2 and 3 go right around the middle of negative 5. I always draw the middle numbers first. It helps me. And then I know 1 is simply between the 2 and 0, and 4 is between negative 3 and negative 5. This isn't perfect, but it helps me. So I know I'm at negative 2. So 1, 2. So I know that my clownfish is going to be, and it works out, it's slightly above that shark. So I'm going to do a C. So I know the clownfish is at negative 2. And again, the octopus is at negative 10 because it's underwater. The penguin is at sea level, so it's 0. And the seagull is above, so it's 10 because it's a positive. It's above. Okay. All right. So next, the vertical distance of a new dolphin from the dolphin that's in the picture is 3 meters. Draw a line to show where the new dolphin's located. Okay, so this is kind of poorly worded, but what it's saying is here we have our dolphin, right? And the dolphin that we have was already at like, it's right here. So I think we said that it was at it's around 3, right? So this is like 3 meters above. So it's just at 3. But there's a new dolphin who jumped higher than this dolphin. And in fact, the new dolphin was 3 meters above this dolphin, right? So they're just saying draw a new line. So 3 meters above just means it's from this 3, it goes up 3 more. So I know that that's going to be at, let's see, well, 3, 4, 5, 6, right? So it went up 3. 1, 2, 3. So my new dolphin, so ND, is at positive 6, right? So just 6. And then we would explain because 3 meters more than 3 is 6. Okay. For some reason, it's not letting me do that. So it's okay to just put in the number. These are little glitches. All right, there we go. So we would explain. Oh, I understand. Okay, so you put the answer. Now I would put in what I had just previously typed in. Okay, so now here's where I want you to pause. I want you to take a second to think about what we were doing. Put these in order from the largest numbers to the lowest. So you can go ahead and pause. Okay? And here's what I'm going to do. Um, I know some students typically have some issues. There's a bunch of numbers in here, right? So what I normally do is there's no rhyme or reason to where you start with this, right? So I'm literally 23 is the largest one I see on this screen, even though I know there's more down here, right? So I'm really just going to start moving numbers compared to that. Whoops. And this is where you got to be. This becomes a pain in the behind, doesn't it? So, all right. So I'm just going to kind of start moving them. Like I know that's above 2. Negative 10. Yeah. 0 is above negative 10, right? And then I'm just going to put these in order one at a time. So I know negative 1 comes right after 0, right? Okay, 8 has to go above 2. 5 is between 8 and 2. Okay. Let's see. I know negative 10, even though 10 itself is a bigger number, I know it's actually below negative 4, right? Oh, positive 10 goes all the way up here. Let's see. Okay, so again, negative 2, I know that that's actually higher up even than negative 4, but it's less than 1, right? Which makes it sound weird, but in the negatives, it's opposite. Okay, 11, let's go way up here. Whoops. Looks like I'm going to have to. Okay. Whoops. Okay. So I think I've done this, but it's very important to go back and check. So I'm literally just going to check and make sure. Am I going with the largest going down? So 23, 22, 15, 11, 10. So each time I'm checking, is 8 lower than 10? Yes. Is 5 lower than 8? Yes. Check, check so far. Now, once I get to 0, I start counting up, technically, right? Even though the numbers are getting lower. So negative 1, 2. So is the number 2, is it getting further away than 0? Yes. 4. Oh, I made a mistake, didn't I? Negative 3 is actually between negative 2 and negative 4. So it's a good thing I checked. Okay. All right. And now here's where we get into fractions. And this is where people can start to get really confused. Okay. Um, for fractions, there's a couple of ways to do this. My personal advice to you is to go ahead and let's make all the fractions, because I also have some decimals in here too. Well, in our last unit, we learned how to make fractions into decimals. And so if we kind of make all of these into decimals, it's going to be a lot easier to then put them in order. Okay? So For instance, if I'm going to do 1/4, that's a fraction, but I need it to be a decimal, right? So I know that in order to change 1/4 to a decimal, it's super simple, right? I'm going to go to a calculator, even though I know this one by heart, which some of you may know by now, and I'm going to take my numerator, the 1, and I'm going to divide it by 4, the denominator, okay? So let's go ahead and do that. So I would take 1 divided by 4. And when I do that, I get 0.25. So that is my decimal for 1/4. Okay. So again, all you do for each and every one is take the numerator and divide it by the denominator, right? Whatever sign it is stays the same. So this will be 0.25. Now, this one, again, sometimes it freaks people out because there's this whole number, right? Well, think about what that means in a decimal, right? If you have a number like this, the the part that's not in the fraction, I'm going to kind of come out here, it's actually going to be the part that goes in front of the decimal. So because 5 is a whole number, it goes in front of the decimal. This one down here, it's negative 22 and 3/8. Well, the 22 isn't part of the fraction. It's actually going to be part of the um, the part that goes in front of the decimal, right? So the rest of it then becomes the same. So let's go back up. We're doing -5 and 5/6. So I'm going to have to change 5/6, right? Negative. The calculation, the part I have to put in the calculator is just taking the numerator and dividing it by the denominator, right? We don't care about this 5 out here because we already know it's in front of that decimal. So I'm going to go back to my calculator. And we're going to do 5 divided by 6. It's actually going to be a long decimal. All right, so 0.8333333. Well, I know that's a repeating 3, right? Because it keeps going on and on. So when I come back here, which I recommend you're writing these down on paper, all right, if you can. So I know that this part here is going to be 8, 3. And remember that repeats. So I'm going to put a little line over it just so I know that that's what's happening. Okay, this is nice because it's a repeat. Yes, I know it's a negative 1/4 instead of a positive, but all that means is what we did up here works. It's the same. So that is just going to be a negative 0.25, right? And then I do the same thing. The 3/8, we didn't do that part. So it's negative 22 and 3/8. All we have to do when we calculate is do the 3 divided by 8. And that's going to give us the decimal part of this number, right? So I'm going to come back. I'm going to do that. 3 divided by 8, 0.375. So that means here it's going to be negative 22.375. Okay. So I, again, would suggest going through all of them first and then finding out their decimal form. Then that way you can put them in order from greatest to least or biggest to smallest. Okay, so why don't you pause, go ahead and do all those conversions, and then put them in order. All right, so I've gone ahead and put the numbers in order. I've also put any decimal amounts that match up with the fractions. Okay, so you can go ahead and check what you did. One thing also that I would like to point out, when I did these, for most of them, I didn't have to use the decimal conversions like I showed you because I was able to kind of already know what some of these were, right? So like I automatically knew this one, well, 5 and 5/6. That means that number is going to be bigger than 5. right? And no other numbers were even, it didn't matter what the decimal was because no other numbers had just 5 holes. Um, 8 thirds. So when I looked at this one, I knew this was one I was going to have to actually convert because of this 2.5, right? I knew that 8 thirds was more than two, right? More than two, but less than three, because 9 thirds would be three. So that told me, okay, let's convert this because I'm going to have to compare it with 2.5. So once I converted this to 2.6 repeating, right, I was then able to tell, oh, okay, that's more than 2.5. So that's got to be above 2.5 or 2 and 5 tenths. Okay. This one, 31 thirds, I automatically knew that's got to be more than 10. It's close to the number 10. And when I did the decimal, by the way, I did that just because I knew 31 divided by 3 is like 30 divided by 3. And I know 30 divided by 3 is 10, right? So I kind of did a lot of mental math. However, you want to do it is fine. Um, Hopefully, eventually, you'll get to the mental math. Um, but if you still have to use a calculator to convert it to decimal, that's fine. Okay? Um, if you converted these to decimals with the whole numbers, um, they should have been fairly straightforward on the positive end, right? They're kind of easy to put in order once you have those decimal versions. But when we got to the negatives, just try not to get too confused on remembering that it's almost like when you get to zero, as we go further down, it's almost like you're counting up again, right? So I automatically knew that negative 1.125 would come above, it's higher than negative 2.5. And then just like before on our number line, if we have a negative 2.5 here, the next number is negative 2.6 because it's almost like we're counting up, even though the numbers are getting smaller. Okay. So you can see that the numbers mirror what was on the other side. Okay. So you can double check your answers. All right, so let's take a look at this. It's saying, suppose we included a new animals, oh, there's a typo, on our graph, animal A, whose vertical distance from the surface is 6 meters. Use the sketch tool to show where animal A could be. So I know that its vertical distance was 6 meters from the surface. Okay, so I can use, let's see, 6 meters from the surface. All right, here's 5. So I know 6 meters from the surface is going to be here, right? So this could be A. Now, Sam says you should have drawn 2 lines. Now, I didn't draw 2 lines, but let's start thinking about what Sam said. Vertical distance from the surface. Oh, okay. So I'm seeing something here. It doesn't say 6 meters above the surface, right? It doesn't. So that means I drew A above, but couldn't it also be 6 meters below? Right? Because this line is still a distance of 6, right? From the surface. These are both 6 meters from the surface. So I actually agree with Sam. And I can explain my thinking. So 6 meters below the surface is the same as distance as 6 meters, whoops, above the surface. Whoops. Okay. All right, so we're going to add in a couple more, but let's see. It says animal B's directed distance from the surface is negative 12 meters. Okay. Use it to show them now. Okay, so negative 12 meters. So I know if this is -10, that means -12 is actually further down, right? So I have to make sure that I'm going to draw a line. I'm going to say that that's going to be B because it's below. And this one says C's is 7 meters from, directed distance is 7 meters from the surface. So because it's saying directed, that's really just telling us that that means it's got to be above because there's no negative sign to show it's below. So we're looking at something like around here for C. Okay. Which one's further from the surface? Well, okay, so we're looking at distance now, right? So B, if I were to go from here all the way to B, 0 to -12 is, that's 12 meters is the distance, right? And for C, if I start at the surface and I go to where C is, that's only 7 meters. So even though the number 7 is bigger than the number -12, animal B is still further away, right? So it is, whoops, B is 12 meters. Whoops, sorry, my dog gets mad at people. And C is 7 meters. Okay, all right. Now we have to put these in order. Okay, so this is kind of the same thing. I know I could use a calculator for this, but I already know 1/10 looks like this is a decimal. 1/10, right? It's 1 in the tenths place, and it is negative, so I'll put that negative there. So we're simply going to put these in order. All right, so let's see here. These are negative. Well, here's a positive number, and I'm going to put that on top because it's bigger than that, right? Okay, so now these are really close to each other, a lot of them. So let's see, which one's closer to 0? Well, let's see. -3 I know is further than -2, right? It goes because once I get to the negatives, we start counting up in a weird way. So -2, -3. -1/10, that's actually in between 0 and -2, right? And then these are the two difficult ones, right? So again, -0.8. If it was positives, 8/10 is more than 1/10, but these are negatives. So the -0.8 is actually between 1/10, 0.1, and 2, -2. So that should be it. Okay, which one's the coldest if this was degrees? Well, -3 is the coldest because that's the lowest number, even though 3 is a big number. Which one? Okay, if these were elevations, elevation is simply height, like our animals. Which one's the furthest away from sea level? Okay, so that answer is actually 7, right? Because 7 is farther from 0, which is sea level, than -3. -3 is only 3 meters away, whereas 7 is 7 meters away, right? And so I can explain that thinking there. Um, and I'm just going to move on since I said it out loud. All right, so reflection. This part of the lesson, I just want you to reflect, right? So, what was a mistake you made that actually helped you understand something better, right? Sometimes making mistakes, in fact, most of the time, making mistakes is really what helps you understand something. So, you're going to tell me something. For 16, you're going to drag the point to show how you feel about the math today. Give yourself some stars and explain. And then that's it. You're going to click that you're done, and you're going to mark this assignment as done. All right. So great job, and I will see you all later.